Okay, I want to start by talking about the general approach to a Ferris wheel problem, and we're going to simplify it a little bit. So we're going to say, okay, so here's a Ferris wheel, not very round, but that's okay. And let's say Joe is right here at 3 o'clock. Let's make it 3 p.m. Here's the center of the Ferris wheel. So in these problems, they give you how long it takes for the Ferris wheel to make one revolution. And we can call that the period, capital T. So let's say it makes one revolution in 120 seconds. Just making this up for now. So they give you that. And generally what they want to know is if Joe starts here, where is he after a certain amount of time? What's his position? And so position in this case means we want to know his x-coordinate and his y-coordinate, which means we have to choose a coordinate system. And in our simplified problem, this most obvious choice for a coordinate system is to put the origin at the center of the Ferris wheel. So there's the x-axis, y-axis. And so in other words, we want to know Joe's position in terms of x and y as a function of t. So this is going to be f of t. That's our parameter. These are parametric equations because we're going to define x and y separately as a function of t. Okay. T, by the way, starts at time 0. And Joe is here. That's his starting position, so that defines where he is at t equals 0. So the first step is we want to find what's called the angular velocity, commonly denoted with a small case omega. Doesn't matter, that's the variable often used. So omega is the units are going to be degrees or radians per second. We'll do degrees. It's easier for me to think in terms of degrees. So degrees per second. And we know the period, which means we know that the Ferris wheel travels 360 degrees in 120 seconds. So W is just equal to that. We just have to divide. So that's equal to 3 degrees per second. Okay, now I'm going to continue on the next page. Let me see if I can add a page. No, that's not what I want. Let me do this. Okay, we'll add a page. So now we know we can forget about period because we know the angular velocity, 3 degrees per second. We've got our coordinate system. And Joe is right here at t equals 0. So and the other thing they give you, of course, is the radius. So let's say the radius is, 20 feet. Okay, I think you know all this, but I just want to review it because you know the general approach, but we just want to define it in real concrete terms. Okay, so simply put, after a certain amount of time, x over r equals, x over 20 equals the sine of, let's call it theta. And theta is simply the angular frequency times t. So xe over 20 equals sine of 3 degrees per second times t, and the corollary to that is y over 20 equals cosine of 3 degrees times t. So those are just general equations, but we're going to use those. So it's, again, making it real general. X over r equals sine wt, and y over r equals cosine wt. Okay, I'll continue on another video.